There will be a city on Mars by the year 2050. It will be humanity's second home, our first outpost beyond the shelter of Earth, and a construction project that cements our future as a multi-planetary species. SpaceX is determined to make this vision a reality, but it will require more than ambition and big rockets to colonize Mars. The key factor that sets a Martian city apart from other off-world colonies, such as a moon base, is the need for true self-sufficiency. A person living on the moon could still return to Earth relatively easily. The journey takes about 1 day, which means any necessary resources could always be resupplied from Earth. Mars, however, is a very different story. A trip to Mars currently takes around 8 months one way. While future nuclear propulsion systems could reduce this travel time, even in the best-case scenario, the journey would still take about 45 days. This means that the people living on Mars cannot depend on Earth for survival. They must learn to extract and utilize everything the red planet has to offer, and what it offers is very limited. This challenge will drive the creation of a massive industrial system on Mars, designed to extract local resources and transform them into the necessities of human life. The long-term goal is that one day, for whatever reason, ships from Earth may stop coming. When that happens, humanity must be able to continue on Mars independently. To make this possible, around 1 million people would need to be living and thriving on the planet before any catastrophic failure on Earth occurs. In other words, humanity must build deep roots on Mars, both figuratively and literally. Before humans ever arrive, Mars will first be inhabited by robots, dozens, perhaps hundreds of them. When humans finally do land, they will follow in the footsteps of these machines. One such robot is Optimus, the Tesla Bot. It is likely no coincidence that a sister company of SpaceX is developing the exact type of technology needed to build infrastructure on Mars. Optimus is a fully autonomous, AI-powered humanoid designed to perform tasks currently done by humans. It can also take on jobs that will eventually be performed by Mars colonists themselves. Mars is simply too distant and too hostile to send humans there without extensive preparation. Unlike historical colonization efforts on Earth, the journey to Mars will be the most dangerous migration humanity has ever attempted. Mars is colder than Antarctica, drier than the Sahara Desert, and subject to massive dust storms. Its atmosphere is so thin that liquid water cannot exist on the surface. It would instantly evaporate. Without a pressure suit, a human body would freeze, boil, and suffocate simultaneously. Even inside a suit, colonists would still face intense radiation due to the planet's lack of atmospheric protection from the sun. Because of these dangers, SpaceX plans to send the first starships to Mars, carrying only Optimus robots. Optimistically, this could happen as early as 2026. According to SpaceX's roadmap, 5 Starship landers would be sent, each carrying 10 tons of cargo. The primary objective of this mission would simply be to land at least one ship successfully. Sending multiple ships increases the chances of success, as early failures are expected. 2 years after the first successful landing, a much larger fleet would arrive. 20 Starship landers, each carrying 75 tons of cargo. Most of this cargo would consist of infrastructure for future human settlers. SpaceX has identified the Arcadia region as a prime settlement location. Located northeast of Olympus Mons, the tallest volcano in the solar system, Arcadia is a relatively flat plain near the equator and is believed to contain large deposits of subsurface water ice. Water will be the most critical resource on Mars. The first major infrastructure project built by the robots will be a water processing plant. Water is essential for drinking, but it can also be split into oxygen and hydrogen through electrolysis. Oxygen will be used for breathing, while hydrogen will be used to produce rocket fuel. Carbon extracted from Mars's carbon dioxide-rich atmosphere can be combined with hydrogen to create methane, the fuel used by SpaceX's Starship. In addition to fuel production, mining operations will be required to access subsurface ice. Excavated soil and rock can be processed into construction materials for roads, landing pads, and buildings. By around 2030, the first human settlers could arrive. Their arrival would require two new projects, a large-scale power plant and permanent habitats. Solar panels combined with large battery systems, such as Tesla's Megapack, could provide reliable energy. While Starship itself can serve as temporary housing, long-term habitats will need to be constructed. Rather than traditional glass domes, early habitats could use ice domes or inflatable structures covered with locally produced concrete-like materials. One such material, known as biocrete, can be made using Martian soil combined with urea extracted from human waste. This may sound unusual, but similar techniques were used historically on Earth. Food production will be one of the greatest challenges. Martian soil contains toxic perchlorates that prevent plant growth. Either the soil must be processed to remove these chemicals or crops must be grown hydroponically. Human waste can again be repurposed as fertilizer once properly treated. If humanity can successfully produce power, water, oxygen, shelter, and food without relying on Earth, then Mars will truly become a second home. This will mark the first real step toward humanity becoming a multi-planetary species.